Day 582 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3578, count partitions with max min difference at most k. The difficulty level is medium, but don't worry because we already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer array nums and an integer k. Your task is to partition nums into one or more non-empty contiguous segments such that in each segment the difference between its maximum and minimum elements is at most k. Return the total number of ways to partition nums under this condition. Since the answer may be too large, return it in modulo 10 to the ninth power plus 7. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 9, 4, 1, 3, and 7, k equals 4. The output is 6. Explanation says there are 6 valid partitions where the difference between the maximum and minimum elements in each segment is at most k, meaning the difference cannot be more than k. So the first way to partition it is we could just partition each number by themselves, right? Because then there is no difference in this because it's just one number. Boom. Then we can partition the 9 by itself, the 4 by itself, the 1 by itself, and we could partition the 3 and 7 together because the difference between 3 and 7 is 4. And since 4 is equal to 4, then that's a valid partition. If it was greater than 4, then it wouldn't be a valid partition. But since it's equal to 4, it's a valid partition. It can also be less than 4. Then the next partition would be 9 by itself, 4 by itself. We could group 1 and 3 together, and 7 by itself. Once again, 1 and 3 has a difference of 2, which is less than 4, which makes it a valid partition. Then we could do 9 by itself, we could do 4 and 1 by itself, we could do 3 by itself, and we could do 7 by itself. And once again, 4 and 1 have a difference of 3, which is less than 4, so it's a valid partition. Then we could do 9 by itself, we could do 4 and 1 together, and we could do 3 and 7 together. 4 and 1 has a difference of 3, which is less than 4. And then 3 and 7 has a difference of 4, which is equal to 4. So those are both valid partitions. And then finally, last but not least, we could do 9 by itself. Then we could do 4, 1, and 3. And then we could do 7. Now 4, 1, and 3, the difference between the maximum element, which is 4, and the minimum element, which is 1, these two have a difference of 3, which is less than 4, which makes that a valid partition as well. And in total, we have 6 valid partitions. Now let's take a look at example 2, just in case that didn't make any sense. So in example 2, we have our input nums equals an array of integers 3, 3, 4. This time k equals 0. The output is 2 because there are 2 valid partitions, right? And there are 2 valid partitions that satisfy the given conditions. The first one, we could just do 3 by itself, and 4. Then we could group 3 and 3 together and do 4 by itself. So when we group 3 and 3 together, they have a difference of 0, which is good, and then 4 by itself is good, right? We cannot do 4 and 3 because if we did a 4 and 3 or 3 and 4, they have a difference of 1, and the difference of 1 is greater than 0, so that's why we cannot partition 3 and 4 together like this. So I hope that makes sense to y'all, and now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult at all. Now, first thing we want to handle is we want to handle this modulo 10 to the ninth power plus 7. So to do that, we'll just say let mod equal. It's going to be an integer. We're going to open up the parentheses, and we're just going to say 1e9 plus 7, just like that. Boom. Then we're going to come underneath that, and we're going to get a rolling sum of the DP values inside the valid sliding window. So we're just going to declare a variable called sum and set that equal to 1. Boom. Now we need the monotonic DQ that keeps track of the minimum value indices, and we need a monotonic DQ that keeps track of the maximum value indices. So for that, we could declare a variable called minQ, and we'll set that equal to DQ less than int greater than, and put the parentheses. Boom. Then we declare another variable called max q, and we'll set that equal to dq, put less than int greater than, and then put the parentheses. Boom. And then we need a left pointer of the sliding window, so we're going to declare a variable called I and set that equal to 0. Boom. Then we're going to say return in.indices dot reduce, open up the parentheses, we're going to say into colon square bracket 1, come outside of that, we're going to open up the brackets, we're going to say dp comma jn, and we're going to come down like this. Boom. Now we're going to maintain the max q as a decreasing dq and remove from the back while the current value n of j is greater, so max q always keeps the largest element at the front. So we're going to say while n square bracket j is greater than n square bracket max q dot last, dot last question mark j, since it's optional, come outside of that, open up the brackets, and we'll say max q dot remove last. Boom, and put the parentheses. Then we're going to come underneath that and maintain min q as an increasing dq, and we're going to remove from the back while n of j is smaller. So min q always keeps the smallest element at the front. So we're going to say while n square bracket j, this time we're going to say is less than n square bracket min q dot last. We're going to say question mark j. Then we'll come outside of that, open up the brackets, and we're going to say max q, oh, excuse me, not max q. This time we'll say min q dot remove last, and put the parentheses like that. Boom. Now we're going to append the current index to both DQs, and it will sit in the correct sorted position because of the above pops. So we're going to come right here and say max q dot append, open up the parentheses j. Then we're going to come underneath that and say min q dot append, open up the parentheses j. Boom. And if the current window I and j violates the condition, then max window minus min window will be greater than k, then incrementally shrink the window from the left. So we come underneath this and we're going to say while let a equals max q dot first, then we're going to say comma let b equal min q dot first, then we're going to say comma n square bracket a, come outside of that, minus n square bracket b, come outside of that, is greater than k. Then we're going to open up the brackets and we're going to remove dp of I from the sum because we are sliding the window forward. So we're going to say sum equals, open up the parentheses, we're going to say sum minus dp square bracket I, come outside of that, we're going to say plus mod, come outside of that, and we're going to say mod, just like that. Then we move the left boundary forward by coming underneath this, and we say I plus equals 1. Boom. Then we're going to remove elements that fall out of the window from the DQs. So we'll come underneath this and we'll say if, open up the parentheses, min q dot first, question mark I, come outside of that, is less than I, open up the brackets, we're going to say min q dot remove first, and put the parentheses. Boom. Then we'll come underneath that and say if, open up the parentheses, max q dot first, question mark I. Then we're going to come outside of that and say it's less than I. Then we're going to open up the bracket and we're going to say max q dot remove first, and put the parentheses like that. Boom. Then we will come underneath this and we'll say dp.append, open up the parentheses, sum mod. Then we're going to add the new DP value to the rolling sum of future windows by coming underneath this, and we are going to say sum plus equals DP dot last, put the exclamation point. Then we'll come right here and we'll say dot last, put the exclamation point just like that. Boom! That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, can I find end and scope? So let's go ahead and just gonna change this to end like this. Boom. Let's run it again, see if that did the trick. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Boom, and look at that, y'all. 44 milliseconds beats -% of users. I don't know what that dash means, but I'll take it. The memory looks good, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.